kilo ohm.
Yes,
Okay.
sir.
So from here I can find out what exactly my circuit diagram is and how my circuit diagram is happening and what is happening in my NPN CC collector amplifier transistors. Yes,
Yes, sir.
fine.
Fine.
Now, okay. So what about this? What about this? I'll just enlarge that circuit. So from there I can find out what is happening in my VCE. So VC, with respect to VCE, what is happening as my VCE is changing, my IC is collector current is
Decreasing.
decreasing. So I can find out. So what is the operating point? We find out. We had a formula. Remember,
Yes, sir.
we had a formula last time. With respect to that, I can find out what is the operating point. Over there, I can find out that is the point and I can draw the line. That will be my particular operating point. Clear? So
Yes,
any
sir.
graph you have to make it out what is happening with respect to my VCE. VCE is nothing but the output I am correcting, and IC. Q is the operating point or operating current. Or so from there I can draw the graph. Okay. Can we take another example of it?
Yes, sir.
Yeah. So I'll use the same collector amplifier circuit which is given in above. Now what I'll do, I'll calculate the input impedance of the transistor base and amplifier stage if the load resistor RL is 10 kilo ohm and NPN transistor current gain is 100. So NPN transistor gain I got what last time? 99 point something.
99.6, sir.
Now the current gain is there. AV is already given. Oh, so yeah. So now current gain is given. What is current gain?
Sir, output current by input.
Output current by input current. Now resistor, load resistor is given. Load resistor means the
RE, sir.
resistor. Whereas remaining thing will remain same. And then you calculate the what will be the output or what will be the answers for all this. The same parameters you have to calculate in this circuit and in this example as well. Clear? So note down this question and practice this. Okay.
Input impedance we should find in this, sir.
Input impedance. What do you mean by input impedance? You have impedance thing, we have load impedance thing, we have studied. Impedance is one formula only. There is only one input impedance we can find out directly. So input impedance is with related to the bias resistance. Resistance is parallel to when your resistance is parallel. So all the resistance whatever is there R1 and R2, with respect to R1 and R2 you have to find the what is the bias resistance first. So first you have to find the R bias. Okay, first you have to find the R bias. So R bias is nothing but parallel configuration of R1 and R2. So you, R1 and R2, if I'll take it as in parallel, so what I have to do, what is the formula I'll get? R1 into R2 divided by R1 plus R2. Clear?
Yes, sir.
So from there, if I have the, so you can say that my impedance input impedance can be called as R bias is parallel to the impedance base impedance. So how you will find the base impedance? Base impedance formula is, I'll just recall, base impedance is equal to Z base. Write down Z
beta
base.
into RE.
Beta into RE plus RE dash. So
Beta
emitter
RE
resistance plus the AC internal emitter resistance.
Sir,
I'll
beta
recall,
into emitter resistance or beta RE dash plus RE dash.
capital R
Yes,
E, capital R E plus small r E dash. Clear?
Yes, sir.
That is your
Input impedance.
no, that is your base impedance. Z and subscript you have to write
Z in base, sir. Z in base, sir.
Z base. Yeah, Z base you have to write. Okay, so transistor base impedance, which always we call it transistor base impedance, Z base. Okay, so what will be the input impedance now? Input impedance is equal to R bias is parallel to Z base.
Then this.
R bias is parallel to Z base. So what is R bias? Both the
Uh,
R1 and R2 is in parallel. Find out with respect to that R bias.
Yes.
And when your R bias is parallel to Z base, again you have to R bias into Z base divided by R bias plus Z base.
Yes, sir.
Clear?
Clear.
Okay. So next we will move what all the applications we have for the CC amplifier. So this amplifier used for the impedance matching circuit. It is used as a switching circuit, the high current gain combined with near unity voltage gain, and it is also used for the circuit isolation. What do you mean by the circuit isolation? What do you mean by the circuit isolation? Anyone?
Sir,
Isolate. Okay. Isolation center. What do you mean by isolation in general English?
Keeping
separating.
alone,
Huh?
sir.
Keeping it alone. So it does its circuit this circuit that acts as a circuit isolation. It means that it separate this particular circuit. So if it is a bunch of circuits are connected, so obviously only amplifier circuit I can't use for the big circuits. Yes,
Yes, sir.
there will be many circuits which will be connected. So this will be helpful for separating this circuit from the other circuit. That's called the circuit isolation technique. Yeah.
Yes, sir.
Yeah. So these are the two important parameters or amplifiers with the different type of parameters and characteristics we have